stopping it accessing the network will also stop it from getting any updates and stop it from being compliant. So what do you want to do when a computer fails its health checks? First, you can do nothing. Simply put, the computer failing the health check is recorded and logged. You can view the log and see which computers need updates. When you first install NAP on your network, it is recommended that you run NAP in report-only mode. The last thing you want to do is stop a lot of your computers from accessing the network when you install NAP. When you first install NAP, look at the NAP logs and see what needs to be done to bring your computers up to date. Bring your computers up to date before you start denying access. Your end users will thank you for it. In the real world, your end users will probably not thank you for it, but in the IT world, no news is often good news. Once you are happy with your settings, you can of course deny access to the network. This can still cause problems. Denying access to the network means the computer can't get any updates. To solve this problem, NAP allows the computer to access a remediation network. When the client connects to a network and fails its health check and is denied access to the main network, the client is however allowed access to the remediation network where it can access updates. Once the computer is up to date, it will then be allowed to access the main network. NAP is very configurable and, depending on the solution you put in place and your needs, will determine if you put a remediation network into place. It is not uncommon for the remediation network to be part of the main network. In this scenario, the computer is allowed access to the network while it is in the process of being updated. In some NAP configurations, you can have both the remediation and main network on the same network. For example, if you are using IPsec for enforcement. With IPsec, the certificate is allowed only once the network check is passed. Without the certificate, the client can't create an IPsec connection. With IPsec, you change the server's configuration to only allow NAP IPsec connections. When deploying NAP, consider if you want to isolate the client on their own network or simply deny them access to parts of the network until they are compliant. There are many different components that make NAP work. On the client, there is a System Health Agent, or SHA. The SHA reports the health of the client to an enforcement point. For example, if you use NAP with DHCP, when the client requests an IP address off the DHCP server, the DHCP will receive a health statement from the client. The agent that provides this health statement comes already installed on Windows Server 2008, Windows 7, Windows Vista, and Windows XP with Service Pack 3. There is room, however, for third parties to develop their own SHAs. These third-party SHAs could add additional checks to run on additional operating systems. Once the client has provided a health statement, this is passed on to a System Health Validator, or SHIV. The SHIV is part of the Network Policy Server component and must be installed on Windows Server 2008. With the SHIV, you can also get it to work with Radius. This is useful, for example, if you want to use 802.1x. The last part of NAP deployment is remediation servers. These are optional on your network, but if you did install them, they would provide things like updates to antivirus and Windows updates through services such as WSUS. As you can see, there are a lot of components to NAP, and there are many different ways you can configure NAP depending on your needs. Let's have a look at a typical NAP layout that may be used in a large company. On this network, when the computer connects to the network, one of three things happen. First, if the computer meets its health requirements, it is allowed access to the production network. For the computer to do this, it must support NAP, and NAP must also be correctly configured. If the computer supports NAP but fails its health checks, it is given access to the remediation network. Since the computer does not meet health checks, it may have a virus on it and thus make it potentially dangerous to work on the production network. To reduce the risk, a read-only domain controller can be deployed on the remediation network. The computer should be able to get updates from this network, but since the network is isolated, should not be able to infect any of the computers on the production network. Finally, if the computer does not support NAP, it is transferred to a guest network. This may be the case if you have visitors from another company plugging into your network. If this is the case, you want them to have access to basic services from your network, like accessing the company website and internet, but nothing else. To do this, a web proxy could be installed so they can access information but cannot access any confidential data or any other company systems. As you can see, there are many different ways you can configure NAP. It all depends on how many servers and networks you want to set up. To start using NAP, you need to decide on what type of enforcement you want to use. I will start by looking at configuring NAP for DHCP, as configuring NAP for DHCP is very simple to set up and a good way to get your feet wet. When a client connects to the network, if they are compliant, they will get full IP configuration and access.